Alright folks, today we're working on 3.3a, which is factoring out a GCF. So first we talk about what a GCF is. GCF stands for Greatest Common Factor, GCF. So the greatest common factor is just the greatest factor that divides two or more terms. And for Algebra 2, we're talking about especially in a polynomial. You probably did these before with simple numbers and maybe single variables like example 1 and 2 here. We're eventually going to get down to doing this with polynomials, which is more than one term. Poly means many, nomial means term. So we've got 3 terms here and 2 terms here and 2 for this and 2 for that. You've probably done something like this already before in Algebra 1. So when I say factor, this just means it is just a term, which could be numbers and variables, or just numbers, or just variables. So we can have a combination of those. So let's look at the first one. Maybe we'll get a handle on it as we go through. So for each of these, we're going to factor out the GCF. So we're looking for the largest term that divides these two numbers. So the largest numbers that divide with 4 and 6. So 4 doesn't divide 6, but 2 divides 4 and 2 divides 6. If you want to think about this, you can make yourself a little factor tree and circle everything that's in common. So break them into primes or product of primes. So 2 times 2 and 2 times 3. The only thing they have in common is a 2. So we can say the GCF of 4 and 6 is just 2. So if I have numbers like this, I'm just asking for you, hey, give me the GCF. There it is, done. Okay, so when we're looking at example 2, we see something different though. We have 2x and 11x. So if we made a factor tree, 2 is prime and 11 is prime, which means nothing multiplies to be them except for 2 and 1, and 11 has 11 and 1. So they have no numbers in common. But there is a GCF. We note there is one x in each of these. Don't forget that if you have x of some power, like x to the n power, that says you've got x times x times x times x, however many times that exponent actually is. So that's n times. In our case, we have an exponent of 1 for each of these, so we have a 1x there. So it says the GCF for each of these is just x, and that's it. That's the whole thing. So these two are if we're not doing these in a polynomial. I'm just asking you for 2 terms, so we've got 4 and 6, or 2x and 11x. Just tell me what the GCF is. But when it's written in polynomial form, we need to do a little something different with it. So we know 4x plus 6. We've got each of these 2 terms. We've got 4x and we've got our 6th term. We know that each of these is divisible by 2 because of this stuff we did up here. We also know that both of them don't have an x in them, so we can't use example 2 over here. So we're going to say that this is equal to 2, and then we actually have to divide 2 or more terms. So we're going to actually divide our terms. So 4x divided by 2 is 2x, and positive 6 divided by 2 is 3. And what we want to be able to distribute and make it go back, so we get 2 times 2x gives us 4x, and 2 times 3 gives us 6, which is what we want. We want our original term back. But if I'm asking you to factor out the GCF, this is what I'm looking for right here. Okay, let's look at example 4. Example 4 is very similar. We might notice a similarity between example 2 and example 4, and example 1 and example 3. So we know from example 2 that we have no numbers in common, but we do have x's in common. So we're going to write down our GCF x. We're going to make some parentheses, spacing out for 2 terms because we have 2 terms here. 2x divided by x is 2, and 2x divided by 11x is just 11. Oh, I ran into a little problem. I'm going to change this problem just a little bit. So 11x squared, which says we have 2x's here and 1x here, so we've got 1x in common, but this is going to leave an x left over. The reason I didn't want to leave it like that is because 2 plus 11 is just 13, and that's not going to get us our original problem. So I just wanted to get a little bit better so it's a little bit more that we could, just the same old as the last one was. Sorry about that. Alright, so x times 2 is 2x. So this is
our GCF. If you would like to go that additional step and check it, just like I did for example 3, you're welcome to, but it's not required. But you should be able to know whether you're right or wrong. Okay, let's look at example 5. So I'm looking at numbers. I see 2x squared plus 8x plus 4, so we've got 3 individual terms. I don't have x's in all of them, so it's not going to be like example 2 or 4 where we have x's in all of them. But I do see a common number we can divide 2 and 8 and 4 by, and that's 2.
So our GCF is just going to be 2. We're going to actually divide 2x squared divided by 2 is just x squared. 8x divided by 2 is 4x's. And 4 divided by, I can actually show it here. 4 divided by 2 is going to give us 2. And we're not going to worry about the rest of this. That's not for this video. The next one, though. So this is the GCF factored form of 2x squared plus 8x plus 4, because if you multiplied it back out, if you distributed, you'd have 2 times x squared is 2x squared, 2 times 4x is 8x, which is what we wanted, and 2 times 2 is 4, which is what we wanted. So factoring is kind of like, let's just write a definition down here at the bottom. So factoring is like the inverse operation. See, inverse operation, aka it undoes distributing. So multiplication, we have our inverse of division. Addition, we have our inverse of subtraction. But factoring is like the backwards version of distributing. So if we wanted to check whether we're right, we can just distribute back out again. We'll make sure we're right. Okay, so example 6, last one. We've got 4x to the 4th y plus 8x to the 3rd y. And what I like to do when I have exponents is I like to write it out just like I showed this example up here. So 4, I've got x to the 4th means x times x times x times x. And then a y from that one. Plus 8, I've got 3x's, x to the 3rd means x times x times x times y. So I'm just going to circle what I have in common for my variables. I've got 3x's here, a y, and a y, which says that my GCF is going to have x to the 3rd and y. We still need to have 2 terms. We're also looking to figure out what our numbers are in common. So of 4 and 8, the biggest number that divides both of those, yeah, 2 does, but I don't think it's the biggest one. Well, wait, 4 divides 4, and 8 divides by 4, so let's use 4 for our GCF. So our GCF is 4x to the 3rd y. So when I divide 4x to the 3rd y, I've got 4 divided by 4 gives us 1. X to the 3rd is going to leave 1x behind, and the y divided by y is going to cancel, so we have just 1x. So 4 divided by 4 is 1. These 3 x's will cancel when we divide. We'll have 1 x left over. The y's will cancel. Plus 8 divided by 4 is 2. X to the 3rd divided by x to the 3rd cancels, and y divided by y cancels. So really I can wrap this up just a little bit by saying this is 4x to the 3rd y times x plus 2. And this is the GCF factored form, because if I multiplied it back out, then we would get back to our original statements. Okay, so this video has just shown you how to factor out using a GCF of both numbers and